Cambridge International GCSE Chemistry Paper 2, tip number 5, alkane reactions. 3 reactions of alkanes are regularly questioned in Paper 2. They centre on combustions, cracking and chlorination. You'll find these questions most often in the range question 31 to 38. Complete combustion has alkanes reacting with oxygen to form carbon dioxide and water. So here's an equation. Here's ethane, C2H6, and oxygen making carbon dioxide and water. Now the numbers of carbon dioxide depend on the numbers of carbons in the alkane. So 2 carbons in the formula gives us 2 carbon dioxides on the right-hand side. The numbers of water molecules depends on the numbers of hydrogens. So 6 hydrogens gives us 3 waters. So to get the balancing for carbon dioxide and water, look at the numbers of carbons for carbon dioxide and the numbers of hydrogens and divide by 2 to give us the moles of water on the right-hand side. Now, obviously, you balance up with oxygen. Perhaps stop the lesson, work out how many oxygen molecules are required to balance this equation. Okay, so I'm going to reveal 3.5 or 7 over 2. So we need 7 oxygen atoms. That's 3.5 times O2. 2 times 2 and 3 times 1 makes 7. 3.5 times 2 makes 7. Now, you may see that represented as an equation, balanced equation, having been multiplied through by 2. So 2 ethanes and 7 oxygens give us 4 carbon dioxides. 2 times 2 is 4, and 2 times 3 is 6. So there's the balanced equation as may be represented. The important feature of carbon dioxide is that it is associated with the environmental problem of global warming. Let's take another example. Propane, C3H8 and oxygen. What are the products? Think it through, speak it out or write it down. 3 carbon dioxides, we've got 3 carbons, so 3 carbon dioxides. 4 waters, we've got 8 hydrogens, so 4 waters. We need to balance for oxygen with 5 O2. 6 oxygens here, 4 there make 10, 5 times 2 is 10. Now, some combustions may be incomplete, for example, in a car engine, and that's due to limited oxygen supply. In which case, instead of forming carbon dioxide, we form carbon monoxide. So here's a balanced equation for the incomplete combustion of propane to form carbon monoxide. Water is still the other product. The problem with carbon monoxide is that it is highly toxic. So there are 2 problems associated with the combustion of alkanes. 1, carbon dioxide is associated with global warming, and in incomplete combustion, a poorly maintained car, you get toxic gas, carbon monoxide. Cracking is the name given to the process by which longer chain alkanes are converted into shorter chain alkanes and alkenes. So a typical reaction equation, C8H18, so that's an alkane, converts into C2H4 and C4H10. We recognize C2H4 as an alkene. It follows the general formula for an alkene, CnH2n. C4H10 is a shorter chain alkane, following the formula CnH2n plus 2. That's the general formula for an alkane. What are the conditions? How did this come about? Well, you may have done it in the school laboratory, you may not. You need a high temperature, you pass hot vapors of the alkane over at a high temperature over a hot aluminium oxide catalyst. You are expected to know those two conditions in some multiple choice questions. Now, what's the huge advantage of alkenes? Why make alkenes? Well, there are two very important, socially important and economically important materials that come from alkenes. The first one is addition polymers such as polythene, polypropene. The second material, ethanol, probably less well known to you, is a very important industrial solvent. Relatively useless or low use large chain alkanes can be converted into alkenes by cracking at high temperature using an aluminium catalyst. From that alkene we get addition polymers and ethanol. We also get the shorter alkane. These shorter alkanes are less viscous, more flammable and make better fuels. This particular equation is not a great example, but should you have a much longer chain here, then it's clearer that the shorter alkane has huge advantages. Nevertheless, the exam answer is less viscous, more flammable, more useful, particularly as a fuel. The third reaction is chlorination. Alkanes undergo substitution reactions with chlorine. That's a common question. In the presence of ultraviolet radiation and not in the dark. So a substitution reaction occurs with chlorine only if there is sunlight, ultraviolet radiation. It will not happen in the dark because the ultraviolet light provides the activation energy. So those three highlighted expressions are key ideas in multiple choice questions. Now, paper 2 reaction equations include, for instance, butane C4H10 plus chlorine Cl2 goes to C4H9Cl, that's chlorobutane, and hydrogen chloride. I've coloured the chlorines blue so you can see that a hydrogen is lost and chlorine substitutes into the alkane. We had 10 hydrogens, we've now got 9 and a chlorine. What's happened to the hydrogen? It's joined with the second chlorine. So this is a substitution reaction which takes place in the presence of ultraviolet radiation or ultraviolet light. Now, let's look at methane and chlorine. Perhaps stop the lesson, jot down what you think the products would be. Come back to check when you're ready. Okay, so we've got 4 hydrogens in methane. One of them is lost to form hydrogen chloride and substituted for with chlorine. What would we call this molecule? Well, I called this chlorobutane, so this would be chloromethane. Methane becomes chloromethane. Hydrogen chloride is the second product, so this is a substitution reaction. Now, of course, you need to attempt some questions from past paper 2s to find alkanes or the reactions of alkanes in the range 31 to 38. If you haven't got access to Cambridge International Education past papers, CIE past papers, go to Maths and Physics Tutor. I've got nothing to do with the website, by the way. It's just a very good website, has unlimited CIE past papers for free. If you've found the lesson helpful, please recommend it to a friend. Please like, and if not inconvenient, please subscribe. Thanks for clicking.